Hey tens, Ellipsis here. Today we're going to learn about how to add, multiply, subtract, and divide decimals. Decimals are just like fractions, except they always have a denominator of a power of 10, like 100. Some terms to know. A decimal is a part of a whole, and in this way it's just like a fraction, except it's written in a different way. Instead of having a numerator and a denominator like fractions, they're written with a decimal point, which is this. But let's get to that later. While fractions can have any denominators, one rule that decimals have is that they must always have a denominator of a power of 10. And so when you're converting fractions to decimals, it doesn't always end up looking nice when it's a decimal. An example is 1/7. A decimal point is the dot that's used to differentiate between the whole parts of the decimal and the fraction or decimal parts of the decimal. So the whole parts of the decimal are basically your ones and tenths. They're your integer parts of the decimal. They're the whole numbers. So it's like a mixed number. When you have a mixed number, you're basically adding a whole number to a fraction. Here, you're adding a whole number to a decimal. And when you do that, they're always separated by the decimal point. And without the decimal point, you can never know that a decimal is a decimal because the decimal point defines what a decimal is. The powers of 10 are the numbers you get when you raise 10 to a power. So 100 is a power of 10, 10 squared. 1000 is 10 cubed. 0.01 is a hundredth, and that's 10 to the power of -2. And you'll learn about negative exponents in algebra. Powers of 10 are important as they enable us to multiply and divide decimals very easily. Without the powers of 10, we wouldn't be able to do it very manageably. Alright, let's take this real number, 34.278,516. Notice how I have not set it as 34,278,516. This is because the decimals are not a whole number, so they aren't supposed to be said that way. Instead, you're supposed to keep them as individual digits. And since I said 34 as 34, you can decipher that 34 is our whole part and these numbers are our decimal part. And you can see that because after the decimal point, it's all decimals. Before it, it's all whole numbers. So let's label the places. Here, 3 is our tens place. This is the whole number. And if you're asking me why isn't it the ten millionths place, it's because, again, everything before this decimal is the whole part. Nothing here is. These are all new places that I'll show you just a second. Four is our ones place. Easy, right? Now we get to the decimals. 2 is our tenths place. Yes, it's very similar. So when it comes to decimals, the place values are basically reversed. It's like positive numbers and negative numbers. Here, instead of this being the tenths place or anything like that, the first digit after the decimal point is your tenths place, And notice the different spelling, because these are decimal places, they are different from our whole number parts. 7 is our hundredths place. Yes, in decimals you always have a th following it. So now you might have noticed that whenever we're going to the right here, our thing is decreasing by 10. So 10 divided by 10 is equal to 1. 1 divided by 10 is equal to 1/10, where you can see that. 1/10 divided by 1/10 is equal to 100th. You can see where I'm getting this from. So if we keep going, 8 is our thousandths place. 5 is our 10,000ths place. One is our 100,000ths place. And 6 is our millionths place. So if we wanted to write this in expanded form based on place value, this would be 3 times 10, which is 30, plus 4 times 1, plus 2 times 1/10, which is 2/10 or 1/5. And so on, until we got to the last digit, our millionths place. So this would be equal to 6 millionths. And you can see the correlation between our decimal digits and fractions, because when we have a digit in our tenths place, our denominator for our fraction is 10. And when we have a digit in our hundredths place, this would be equal to 7/100ths, or this. You can see that the denominator is 100, while fractions can have any denominator they choose. Decimals must have a denominator of a power of 10, which is why it makes it so hard to convert some fractions into decimals. For example, pi, and pi doesn't have a fraction equivalent because it's really crazy. Alright, so let's move on. So how do we add decimals? Let's start with this. First of all, we need to line up our decimal points. And I'll show you why this is important in the next slide. Then we need to add zeros to the end, if needed, where needed. Again, I'll elaborate on this in the next slide. Then we add like we do with integers. And yes, if there's regrouping, we need to do that too. And then in the end, we put the decimal point at the same lining. So wherever your decimal points were lined up, we need all our decimal points to be lined up in the same way. So let's try some. Let's take the first one. 6.08 or 6.08 plus 7.76. So let's lay this out like we would do it normally. Let's just put 6.08 over 7.76 and just lay it out like that. Notice how I have my decimal points in the same place. So however many places we have on one side of the decimal point, we need to have the same amount of places on that side, which enables us to add these very nicely. So let's do this. 8 plus 6 is 14, so there's our regrouping. 1 plus 7 is 8, and 6 plus 7 is 13. Now, where do we place the decimal point? Again, we need to place the decimal point where these are lined up. So we place it here. A tip to finding where we need to put the decimal point is that however many places are on the right side of the decimal point, or however many decimal places are on the side of the decimal point, we need to have that many on this side. And it's slightly different here, so I'll just show you now. But before I do, I encourage you to pause this video and try this out using the steps shown here. Alright, I guess you're done. So now let's do this. 2.9 plus 4.83. We can see that this is different because they don't have the same amount of decimal places here. So let's just lay this out. And I prefer to put the number with more decimal places on top because it gives me the impression that the larger number is on top. So 4.83 plus 2.9. But where are we going to put the 2.9? Are we going to put it here or here? Well, we need our decimal points to line up. So we need to put the decimal point here. So let's just put that there. Then line up the rest of our places. So 2 goes on this side and 9 goes on this side. But wait, we don't have the same amount of decimal places on this one as we do on this one. So what we do is add a 0 to the end. Now, if you're thinking that I changed this number now, I have not changed it in any way. Adding a 0, what it basically does is you're adding 0. So if I expand this, 2.9 is equal to 2 times 1 plus 9 times 1/10. This is equal to 2.9, right? And then if I add 0 times 1/100th, well, 0 times anything is equal to 0. So I'm literally adding nothing here. But this makes it a lot easier for me to align my places. So now let's add these. 3 plus 0 is 3. 8 plus 9 is 17. So we put that up here. 1 plus 4 is 5. Plus 2 is 7. And we need to keep our decimal points aligned, so we put this right here. And 7.73 is our answer. Let's move on to the next slide. How do we subtract decimals now? Well, it's basically the same as adding, except now we're subtracting. First, we line up the decimal points, then we add the zeros to the end where we need to, and then we subtract like we do with integers, and borrowing if required. And then we put the decimal point at the same area after subtracting. So let's try some examples. 10.2 minus 2.7. Let's put these in the same layout as we did in the other slide. Oh, but now we have a problem. Where do we put it? Well, we want our places to align, so in order to do that, we need our decimal points to align. So we put the decimal point right here and put our digits in now. So 2 is in the ones place, and the 0 is in the ones place as well. So we put the 2 underneath 0, and 7 is in the tenths place, so we put it under 2. And there we have it aligned. So now we can see that we don't have to add any zeros to the end because we had the same amount of decimal places to the right of the decimal point. So let's subtract. 2 minus 7, we can't do that, so let's change this to 12, and we need to change this to 9, and change this to 0. Because, yeah, you know the rules of subtracting, right? Because if you don't, you shouldn't be watching this video. So 12 minus 7 is equal to 5. Then let's add the decimal point right here. 9 minus 2 is equal to 7, and 0 minus 0 is 0, so that's 7.5 for our answer. Now let's go to this one. 8.24 minus 6.1. So let's lay this out. Oh, but now how do I do this? Again, we need to align our decimal points. So we put the decimal point here. 6 is in the ones place, so we put that under 8. And 1 is in the tenths place, so we put that under 2. And remember, we can add however many zeros we want after this 1 or after this 4. It doesn't change the decimal in any way. So we can just add a 0 here. And now let's subtract. 4 minus 0 is 4. 2 minus 1 is 1. Let's put the decimal point. And 8 minus 6 is 2. That was easy. No borrowing like this one. So we are given the answer 2.14. And if you were doing mental math with this, you would have gotten the same answer. Alright, let's move on to the next slide. How do we multiply decimals? We don't need to line up decimal points for either multiplication or division. But we anyways do division in a different way than multiplication, so let's leave that aside for now. So we multiply just like we do with integers, ignoring the decimal points for now. And then, once we're done, we count all the decimal places that are after the decimal point, and then put the decimal point before all of those places in the final answer. And if this doesn't make sense, I'll show you in the next slide. Alright, let's do these examples. Let's take the first one. 12.32 times 6.2. Okay, let's lay this out like we did the addition and subtraction. And remember, we don't need to align the decimal points, so let's just line them like we would with integers. And I'm just going to put this as 6.2, just normal digits. And we're just going to multiply normally, like they were never decimals in the first place. So 2 times 2 is 4, 2 times 3 is 6, and we ignore this decimal point for now. It'll come in handy later. 2 times 2 is 4, 2 times 1 is 2. Then a 0 here. 6 times 2 is 12. 6 times 3 is 18, plus 1 is 19. 6 times 2 is 12, plus 1 is 13. And 6 times 1 is 1, plus 1 is 7. Then add these. Okay, we have our final answer. Except it's not quite our final answer. We still need to add the decimal point. Because if you're doing an estimate, you would choose 12 times 6. And 12 times 6 is not approximately equal to 76,384. It's equal to 72. So we need to add the decimal point. And before I show you how we add the decimal point using that estimate, 12 times 6, I want you to try it out and let me know where you think you would put it in the comments below. So let's do this. Since we have this huge 5-digit number here, where we put our decimal point is we count all places that are here that are after the decimal point, not before, after. So these 3. And since we have 3 decimal places after the decimal point combined with these 2 numbers, we have 3 places after the decimal point here. But which way do we go from? The right or the left? We go from the right, obviously. So if our decimal point is here, 1, 2, 3 decimal places to the right. So our final answer is 76.384. And that was close to our estimate, 72. So this is a reasonable answer. Let's go on to this one. 8.4 times 2.7. Alright, let's do this. And notice that the decimal points line up. It's just normal. Sometimes. So let's do this. 7 times 4 is 28. 7 times 8 is 56, plus 2 is 58. Then a 0. 2 times 4 is 8. And 2 times 8 is 16. 8 plus 0 is 8. And I'll just keep going. And so we have 2,268. But we know that's not our final answer, because if we do our estimate, 8.4 can be rounded down to 8, and 2.7 can be rounded up to 3. So since 8 times 3 is 24, our answer is going to be around 24. So again, let me know in the comments below where you think the decimal point goes. Now, if you've done the same thing that I've done here, it means that we have 2 decimal places after the decimal points in both numbers. So we go 2 decimal places and put our decimal point here. So our final answer is 22.68. Sorry for my hoarse voice. I've been talking for quite a while. Lecture me. So, how do we divide decimals? We use long division. And in my opinion, long division is the best way, the most concrete way you can divide decimals. So what we do is we move the decimal point as many places to the right by multiplying by a power of 10 to make the divisor an integer and not a decimal. If the divisor is already an integer, we don't need to worry about anything. And same thing with the dividend. We want to keep things equal. And again, this is a prominent rule in algebra. Whatever you do to one side, you do it to the other side. So once we do these, we just divide normally and we will get our answer. And a cautionary tip, be sure to put your decimal point if there is a remainder. So let's do this. Let's take the first one. 6.3 divided by 2.1. Now I have specifically made sure that there will be absolutely no remainders. So there will be no decimal points because it would be too messy. And I don't have a lot of time in the first place. So let's do this. Let's put this in the long division layout. And some of you might prefer this one, some of you might prefer this one. I don't care. I'm just going to go with this one because that's the most popular. So let's do that. 6.3 is our dividend, 2.1 is our divisor. So what I like to do is I like to put the decimal point straight up so that I can keep my places all in line. And if I'm not able to do by something, then I'll just put a 0 over there. But first, let's make this an integer. No one likes keeping the divisor a decimal as it makes it intensely hard to divide the decimal. So what we do is we move this decimal point 1 to the right. And what we do to this, we need to do to this. So we move this 1 to the right as well. And what you're basically doing here by moving the decimal point 1 to the right is basically you are multiplying this number by 10. So 2.1 times 10 is equal to 21, okay? It's basically moving this to the right. If it was here, you're moving it here, so now this is 21.0. Get it? Alright. So now let's rewrite this division problem. And this is going to be 21 divided by 63 now. And now, since our decimal point is here, we've got to put it up here. And now let's just divide normally. 21 goes into 6. 0 times, so that's that. That's 0, big fat 0. And 21 goes into 63 3 times. So 21 times 3 is equal to 63. 63 minus 63 is equal to 0, and we are left with no remainder. And our answer is 3. So 6.3 divided by 2.1 is equal to 3. Now if you're asking me, why isn't it 0.3 or why isn't it 0.03 like in multiplication? This is because since we did the same thing to both sides, we multiplied 2.1 times 10 and we multiplied 6.3 times 10. We multiplied them by the same number, and so in this way we kept things equal. You will see this a lot in algebra. So 3 is our answer. Let's go to the next one. 300 divided by 6.25. So let's write that out. 300 divided by 6.25. Again, if you're being tricked by this being a whole number and not a decimal, we want this one to be an integer. We don't need this one to be an integer. It can be whatever it wants. So we need to move this 2 decimal places to the right, or multiply this by 100. And whatever we do to this, we do to this. And if you're asking me, where is the decimal point here? I don't see one. Decimal point is right at the end, because you can add a 0 at the end, and that means 300 plus 0/10, which is 0, and 300 plus 0 is 300. So we move these 2 decimal places to the right too. But what is here? Just empty space? No, there are zeros. Remember, there are infinite zeros after the decimal point if this is a whole number, or sorry, integer. So we just add zeros here. So if we rewrite this division problem, this is 30,000 divided by 625. And again, this is equivalent to this. So whatever we get for this, that's what this is equivalent to. So let's solve this. And before we solve it, I encourage you to pause this video and just try it out. I've pretty much done most of the work for you. Alright, let's do this. 625 goes into 3 0 times. And again, I'm putting the decimal point here. 625 goes into 30 0 times. 625 goes into 300 0 times. And yeah, this is tiring. But 625 does go into 3000 more than 0 times. So that's finally a relief. So 625 goes into 3000 4 times. And 625 times 4 is equal to 2500. Okay. So 3000 minus 2500 is equal to 500, and we just add that 0 at the end, and 625 goes into 5000 8 times. So 625 times 8 is 5000, and 5000 minus 5000 is equal to 0. So we are left with the answer 48. So 6.25 goes into 300 48 times. Yay, we did it! Thanks for watching. If you liked this video or this helped you, click that like button. If this didn't help you, click that dislike button. I greatly appreciate feedback. If you want more updates on new videos, click that subscribe button and turn on notifications. If you have any questions related to this topic, put those in the comments below. And remember, the comments section is the equivalent of a class discussion, so if you have answers to any of the questions, you can answer them. If you have any suggestions as to how I can improve my future videos, or even suggestions on what I should do next, put those in the comments below as well. If I like your suggestion, I'll be sure to include that in the next video and give you a shout out. See you in the next one!